Hello and good evening. Welcome to Math with Phyllis. Today we want to handle partial fractions. We have partial fractions are commonly used in integration as a tool or a technique for integration. We have four scenarios for decomposing. We have four categories. The first category is when we have linear factors, where the denominator has linear factors, and linear factors are often gotten after solving quadratic equations or cubic equations. For example, we can have 5x over 1 minus x plus 2. That's a linear factor. The other scenario, we have repeated factor as the denominator, the repeated factors. For example, we have 2x over x plus 1 squared. Lastly, we have the nonlinear factors, and by nonlinear factors we mean these factors cannot be factorized. They are called the nonlinear factors or other factors. For example, you can be given 6x over x squared plus 1. X squared plus 1 cannot be factorized. And then lastly, we have scenario whereby we have the power of the numerator is greater than the power of the denominator. We have some cases where power of numerator exceeds the power of the denominator, and in this case, if you are given such a scenario, you will divide the two polynomials or the two equations until you get a power which is less than that in the numerator. So in today's video, we are going to deal with the linear factors before continuing to the other factors in subsequent videos. We have an example whereby you are asked to decompose into partial fractions. You are asked to decompose into partial. We're given 5x plus 7 over x plus 1 x plus 2. The values in the denominator, we can see those are linear factors, so it's quite straightforward. We will have a over x plus 1. When we decompose, we will have two fractions plus b into x plus 2, and the two are equivalent. That's why we're using that sign. That means we will get the LCM of the denominator, which takes us back to x plus 1 x plus 2. We proceed to solve in the normal way. We will have a into x plus 2 plus b into x plus 1, which is equivalent to 5x plus 7 over x plus 1 x plus 2. We have x plus 1 x plus 2. The two are equivalent, so the denominators are the same. That means the numerators will also be the same. We can have 5x plus 7 to be equals to a into x plus 2 plus b into x plus 1. We need to get the values of a and b. We will move ahead and see. If we want to eliminate a, then it means we will have to add x to be negative 2, and if we want to eliminate b, that means x will have to be negative 1. So we will say if x is negative 2, we substitute the values both to the left and to the right. We will get negative 10 plus 7 is equals to b into negative 1. That means negative 3 is equals to negative b, which leaves us with b to be 3, because the negative and the negative will cancel out. And now we want to eliminate a. We will get x to be negative 1. We want to eliminate b, sorry. That means we will have negative 5 plus 7 will be equals to a into -1 plus 2. That gives us the value will be 2 is equals to a. So we can see our value of a is 2 and our value of b is 3. Now that means when we decompose, therefore when we decompose 5x plus 7 over x plus 1 x plus 2, it will give us a value. We have x plus 1, let's just write that afresh. X plus 2 will give us a is 2 over x plus 1 plus we will have b is 3 over x plus 2. That's how we get, and now if it's in integration you can proceed and integrate. But for now that's all. Thank you. Bye.